Welcome you all for the electronic devices and circuits of unit number 1 of the BTech third year semester students. Myself Rohini Kochi. We will deal about the topic that is nothing but the PN junction diode. So these are the course outcomes of the subject EDC. In unit number 1, the interpret the applications and operating principles of the different diodes like a PN junction diode, Zener diode and the semiconductor devices. This unit contains the semiconductor diodes, PN junction diodes, their application, physical structure of the diode, characteristics, resistance, capacitance and its applications, clipping clamping circuits, how the Zener diode will be working as a voltage regulator, Schottky diode, varactor diode and the tunnel diode. So we will now discuss today's topic is the PN junction diode. The PN junction diode is nothing but the material of P and N type of material which is combined together and forms the diode, that is nothing but the PN junction diode, which is made up of the silicon material which is doping with the impurity material like a trivalent and the pentavalent impurity, and the boundary formed by adding this impurity is nothing but the PN junction diode, which is resulting between the P type and N type of portion. So in the PN junction diode, the basics of the diodes such as certain transistors, solar sets and other devices, we are using the PN junction diode. A diode is nothing but a device that will connect currents only in one direction. So the PN junction is the feature that allows the diode, certain transistors and other devices to work. If we take a piece of intrinsic silicon which is doped so that the part of N type and the part of P type, that will be forming a junction, and the boundary between these two regions of the diode is to be showing in the figure. So this is nothing but the formation of depletion layer. The free electrons in the N regions are drifting in all the directions, and at the instant of PN junction formation, the free electrons from the N regions and the holes from the P region, they are diffused across the junction and forming the region that is nothing but the depletion layer or the junction potential or the barrier potential. We can say it as a junction potential or the barrier potential. So by recombination of holes and electrons near the junctions, got a PN junction, that is nothing but the formation of depletion region. So when the PN junction is formed, the N region will loses the free electrons and they will diffuse across the junction, and this creates a layer of positive charges across the junction, that is by adding the pentavalent impurities near the junction. As the electrons move across the junction, P region loses the holes as the electrons and the holes recombine, and this creates a layer of negative charges, that is trivalent ions near the junction. So in this way the depletion layer will be forming at the junction. These two layers of positive and the negative charges which forming the depletion layer as shown in the figure. So another name for the depletion region is nothing but the barrier potential, or we can say the junction potential. So anytime there is a positive charges and negative charges which is nearer to the junction, and force acting on the charges are described by according to the Coulomb's law. So in the depletion region there are many positive charges and many negative charges on the opposite sides of the PN junction. These forces between the opposite charges forming an electric field by the blue arrows which are showing in the junction, and they can be electric field will be generated. Thank you.